Good afternoon and welcome back to part 3 of our module 3 instrumentation. So our next topics will be about electrophoresis, its parts and components, chromatography, and other principles of our clinical chemistry analysis or determination of analytes. So electrophoresis is the migration of charged particles in an electric field. So kailangan may charge para mag-migrate yung ating samples or analytes na i-measure natin para sa ating patients or sa samples. So the principle is ionized amphoteric molecules will move either to the cathode, the negative electrode, or the anode, the positive electrode. So depending on the charge or the net charge of the molecule. So kung ano yung charge ng ating molecules, dun siya pupunta or magmamigrate. It is the movement of electrically charged compounds in a medium resulting to the separation based on their electrical charges when an electric current is applied. So kapag nilagyan natin ng electricity or kuryente, yun yung ating magsaserve na pampagalaw ng ating samples. So cations or cations move toward the cathode, anions move toward the anodes. So cations have positive charge, anions have negative, and they move toward the respectable anodes or cathode. So kung saan siya naka-charge, dun siya pupunta. So charge-colored particle or ion will migrate toward an ion, toward either the anode or the cathode under the influence of externally applied electrical field. So paglagay natin ng kuryente, yun yung charge, magkaka-charge siya. So, depende sa charge kung punta ay sa cathode or sa anode. So, the migration will depend on the following. So, electric charge of the molecule that is given at a pH. So, halimbawa, acidic pH buffer. Pupunta siya sa molecules R positive and migrate toward the negatively charged electrode. So, for alkaline pH buffer, molecules are negative, so mga anions, and they migrate toward the positively charged electrode. So electrophoretic mobility is proportional to the net charge, so depende sa charge. A particle without a net charge will not migrate and remains in the point of application. So meron tayong mga walang charge na ating mga samples or kung ano yung ating i-measure na analyte, tapos hindi siya magmamigrate. So doon siya or doon natin i-measure. So pag may naiwan doon, pwede natin ma-measure yung analyte na yon. Depende kung saan siya nagpunta. So the migration will also depend on the particle size and shape. Electrophoretic mobility is inversely proportional to the molecular size and viscosity of the supporting medium. So depende sa size, kapag malaki, mas mabagal yung migration niya. Ganun din sa viscosity, pag viscous, mabagal yung migration ng ating particles. Electric field strength. So, higher voltage, mas mabilis yung kanyang migration. Nature of the supporting medium. So, depende kung ano yung medium yung ginamit natin or yung pinaglagyan nung sample na ating electrophoresis. So, cellulose, acetate, and agarose gel. Sila yung most commonly used for protein electrophoresis. Affected by electroosmosis and or endoosmosis. So electroosmosis is the flow of ions toward the negative cathode. So polyacrylamide gel, ito naman is not affected by endoosmosis. Another factor is the temperature of operation. Higher temperature equals faster migration. Buffer or our ionic strength, buffer ionic strength. Lower ionic strength, so siya ay better separation, less resolution, faster migration, and longer pattern. Paano naman yung higher ionic strength? So, better resolution, lesser separation, slower migration, and slower pattern. So, the ions carry the applied electric current and allow the buffer to maintain at a constant pH during the electrophoresis. The more the pH of the buffer differs from the isoelectric point, the greater the magnitude of the net charge of the protein and the faster it will move toward the electric field. So, depende sa ating buffer yung kanya ding migration. Okay, next is the components of our electrophoresis. So electric power, so that is 100 to 200 volts for about 25 minutes. Ito yung ating external source kung saan ito yung nagbibigay ng charge sa ating particles. Support medium, so pwedeng paper. So the paper is the oldest support medium. It is no longer used. Cellulose acetate, so it is the replacement for paper. Separates based on the molecular size. Next, so cellulose acetate pa din. Advantages niya, substance clears with alcohol and controlled heat or acetic acid plus alcohol. Excess dyes extracted rapidly from the background. So, natatanggal agad yung ating dyes. Migration occurs in a short time, usually 20 to 60 minutes. Can be used for isoenzyme and hemoglobin fractions. So, tough when wet. So, matibay daw siya pag binasa. Next is agarose. Separates by electric charge. It does not bind protein. So, advantage nito is the reproducibility. So, madali siyang paulit-ulitin or ulitin ang ating test na ginawa. 7 to 8 distinct protein bands or improved resolution. So, no clearing required and increased sensitivity. Last is the polyacrylamide gel. So, the polyacrylamide gel separates on the basis of charge and molecules. So, not affected by endoosmosis and separates proteins into 20 fractions used to study isoenzymes. So, hanggang 20 yung kanyang fractions na pwedeng gawin. So, isoenzymes kasi yung ating enzymes, may para siyang magkakaibang hawig. Hawig siya pero iba lang yung kanyang chemical molecular arrangements. So, same siya ng chemical formula, iba yung arrangement niya. So, yun yung ating isoenzymes. More on that on your second year or your second chemistry or CC2. Next component is the buffer. So, the buffer carries out the applied current galing sa ating kuryente, yung electric source. The pH of the buffer determines the charge of the protein molecule and therefore its direction of the migration. So, depende kung yung ginamit natin buffer, doon siya nakabase. At pH 8.6, all proteins are negatively charged and migrate toward the anode. So, example is the sodium barbital. Sampling and detecting system. After electrophoresis, the gel is treated with a mild fixative. So, if i-fix natin siya, para ating ma-stain. Kasi, mawawala siya pag hindi mo finix. Such as acetic acid. So, that precipitates the proteins at the position at which they are or they have migrated. So, pagkatapos ng migration, i-fix natin siya para mag-stay or ma-hold doon yung ating samples, tapos saka natin siya i-stain. So, they are stained and the gel is dried and cleared of excess stain. Tapos yung stain na yun, yung ating i-check para sa ating concentration. So, stains for visualizing of fractions. So, amido black, Ponchiao S, oil red O, Sudan black, pot red 7B, Couaminase blue, gold or silver stain. So, gold and silver stain are the most sensitive and they can detect nanogram quantities of proteins. So, all stains or stains must bind all fractions equally. Then, cytometry. So, this measures the absorbance of the stain and the concentration of the dye and the protein fractions. So, after natin ma-stain, ma-measure natin siya using densitometry. So, it scans and quantifies the electrophoretic pattern. The measurements are reported in grams per dl. Precautions. If the electrodes are not properly aligned, the current may be denser on one side of the gel kesa sa kabila. So, pag hindi naka-align siya, pwedeng abnormal or unbalanced, hindi equal yung distribution ng kuryente. Proteins will migrate farther on one side with more current. So, pwedeng unequal siya, hindi siya magiging accurate yung ating reading. If electrophoresis proceeds too long, the proteins may migrate off the gel into the buffer. So, pwede siyang lumampas do sa ating media or sa medium kung saan siya natin nilalagay. Precautions ulit. If there is a break in the electric current or circuit, and no current passes, the protein will not move from the point of application. So, hindi siya gagalaw or hindi iipon, magmamigrate yung ating samples. Small artifacts. So, these are samples at the center of the gel that migrate farther than those at the edges. So, naiiwan yung iba. Uses of electrophoresis. So, they are used for the screening of protein abnormalities, fractionation of isoenzymes, identification of abnormal hemoglobins, phenotyping of lipoproteins, identifying the type and class of abnormal protein by reacting it with a specific antibodies. So, ito yung mga special uses natin. Madalang naman tayo nito sa usual routine na chemical laboratory. Usually, mga special laboratories yung meron nito. Isoelectric focusing. So, it is the separation of molecules by migration through a pH gradient similar to electrophoresis. Principle. The principle is pH gradient is created by adding acidic or acid to the anodic area of the electrolyte cell and adding base to the cathode area. The separating molecules migrate into an area where pH is equal to their isoelectric point. So, pupunta siya sa kung saan yung pH niya mismo para magmamigrate siya papunta doon. Proteins move into the electric field until they reach a pH equal to their isoelectric point. Movement of molecules are based on pH. So, they are ideal for separating proteins of identical sizes but with different net charges. So, kapag net charge yung gagamitin natin pang detect, ito yung ginagamit. Advantages, they are able to resolve mixture of proteins. So, kapag kasi protein, pwedeng same size sila, kaso magkiiba sila doon sa charge, tsaka doon sa kanilang chemical composition. So, they detect isoenzymes, and they identify genetic variants of proteins such as anti-1 antitrypsin. They also detect CSF oligoclonal banding. Capillary electrophoresis. So, samples molecules are separated by electroosmotic flow. So, positively charged ions in the specimen emerge early at the capillary outlet because of the electroosmotic flow, and the ion movement are in the same direction. So, negatively charged ions in the specimen move toward the capillary outlet but at a slower rate. Uses. So, uses nanoliters of quantities of the specimen. Kaunti lang yung kailangan nating specimen para dito. Used or saan siya ginagamit? So, separation and quantitation and the determination of molecular weights of protein and peptides, analysis of PCR products, and analysis of organic and inorganic substances and drugs. So, mga madadalang ito. Hindi pa ako nakapag-try nito. Next is our chromatography. So, chromatography is a technique wherein the solutes or solutes in a sample are separated for identification based on physical differences that allow their detection distribution between a mobile phase and a stationary phase. So, mobile phase, ito yung either mga inert gas or mga liquid. Stationary phase may be silica gel bound to the surface of a glass or plastic sheet. May be silica or polymer that is coated or bonded within a column. So, they involve separation of soluble components in a solution by specific differences in physical and chemical characteristics of different constituents. So, the principle of a chromatography is the mixture can be separated into individual components on the basis of specific differences of their physical characteristics. The separation of chemical mixtures into different components based on their physical characteristics, and the introduction of molecules with the mobile and stationary phase through the support medium. So, magpapahanap tayo ng video para madali nyo siyang magets depende sa kanyang paggamit mismo. So, techniques used in separating complex mixtures on the basis of different physical interactions between individual compounds in the stationary phase. So, malimit pinaghihiwalay dito yung stationary tsaka yung mobile phase natin. So, the goal of this technique is to produce fractions for quantitation. So, pagkakahiwa-hiwalay lang din para makita natin yung magkakaiba or yung magkakahiwalay na molecules ng sample. So, basis of separation, pwedeng rate of diffusion, solubility of the solute, nature of the solvent, sample volatility or solubility, distribution between two phases, and the molecular size. Hydrophobicity of the molecule, depende sa water. Ionic attraction. Differential distribution between two immiscible liquids, so yung mga liquid na hindi natin mapag-separate. Selective separation of substances, pag may specific tayong kailangan. Differences in adsorption and desorption of solutes. So, ano ba yung mga form natin ng chromatography? So, una is planar or planar. So, paper chromatography. Used for fractionation of sugar and amino acids. So, pag pinaghihiwalay dito, yung sugar and amino acids. Separation is determined by the rate of diffusion of denong dalawa, solubility of the solute, and the nature of the solvent. Stationary phase, ang gamit natin is Whatman paper. So number 2, thin layer chromatography. So the mobile phases moves toward the stationary phase by absorption and capillary action. The principle is a stationary phase is a thin layer of fine particles of a sheet of glass or plastic. Mobile phase is a mixture of solvent or solvent in a mixture. So yung sample natin nandun. Sample is applied on lower edge and carried upward toward the solvent separation by differences between the solvent and the sorbents. So the basic steps in our chromatography is sample extraction using a liquid or column technique, concentration of the extracted sample, sample application by spotting on a silica gel plate, development of solute in the sample using stationary and mobile phases, solute detection using chromatographic sprays, UV light, and fluorescence and heat. Interactions of chromatographic results utilizing RF values. So RF values is retention factor value. So relative distance of the migration from the period of application. So meron doon natin ibinabasa yung concentration ng ating samples. Used for semi-quantitative drug screening tests. Each drug has a characteristic RF value, and it must match the RF value of each standard drug. So, depende sa pattern. Kung paras yung pattern, mo-consider natin siya para doon. Sample components are identified by comparison with standards on the same plate. So, standards, ito yung ating pattern na gagayahan. So, parang sabay yung niraran, yung sample, tapos yung standard. So, kung magkamukha siya or pareho, ibig sabihin, parehas yung ating sample and the standard. So, other forms of chromatography, yung ating planner kanina then is columnar. So, gas chromatography, used for separation of compounds that are naturally volatile or can be converted to gas. It has high resolution, accuracy, sensitivity, and short TAT. So, ano yung ating TAT or TAT? So, ang ating TAT is turnaround time. Kung gaano kabilis mararan yung ating samples or matatapos yung test. Components of gas chromatography is gas tank. So, this contains or sources of gases for the mobile phase. So, mobile phase, ito yung ginagamit natin, yung mga gas. So, either nitrogen, helium, argon, hydrogen, CO2, NH3, and nitrogen. Nitrous oxide, NO. Injector, so introduces the sample to the machine. Samples are heated and vaporized, then introduced. If volatilization cannot be carried out, the derivation of substances into a more volatile form is done, either by silylation, alkylation, and acylation. Column, so ito na yung ating pinaglalagyan o kung saan may kita yung molecules. So it is where interaction between molecules take place. Packed column, large sample capacity. Capillary column has higher efficiency and better detection limits. Next component is the detector. Pwedeng flame ionization detector, thermal conductivity, nitrogen phosphorus, electron capture, flame photometric, mass spectrophotometry. Last is data system. So, dito na yung nagko-convert yung nababasa nating electric charges from the detector. Kasi from detector, saka siya babato sa data system. Then yung data system yung mag-i-interpret ng data, saka niya i-release yung results. So, other types is gas chromatography, either gas solid or gas liquid. So, gas solid chromatography separation occurs based on differences in absorption at a solid phase. So, liquid naman occurs differences in solute partitioning between the gaseous mobile phase and the liquid stationary phase. So, mass spectrophotometry. This is based on the fragmentation and ionization of molecules using a suitable source of energy. It can also detect structural information and determination of molecular weight. Before a compound can be detected and quantified by mass spectroscopy, it must be first separated by gas chromatography. So, mass spectroscopy, So, meron tayong GCMS, Gas Chromatography, Mass Spectroscopy. So, gold standard for drug testing. So, ito yung pinakang ginagamit or pinagbabasehan natin. In this method, quantitative. So, naka-quantitate natin yung drugs. Tandem mass spectroscopy. So, they can detect 20 inborn errors of metabolism from a single blood spot. So, dito natin binabasa yung parang newborn screening. Pero sa newborn screening kasi, hindi lahat kailangan or may ilang tests lang na kasama doon. So, ito, pag tandem mass, pwede ang 20. So, next is liquid chromatography. It is based on the distribution of solutes between a liquid mobile phase and a stationary phase. So, analyzes substances that are not readily volatile. So, hindi nag-evaporate. Uses low temperature, suitable for thermolabile compounds. So, mahina sa temp. Yung may hina sa lamig. Separation mechanisms used in liquid chromatography. Number 1 is gas-gel filtration or the molecular sieve chromatography. Separates based on size and shape. As solutes travel to the gel or through the gel, large molecules remain in the mobile phase and are eluted rapidly from the column. Hydrophilic gel or so gel filtration. So ito for separation of enzymes, antibodies, and protein. Example is dextaran and agarose. Hydrophobic gel, so gel permeation. Separation of triglycerides, so TG is triglycerides and fatty acids. Example is Cefadex. Ion exchange chromatography. So separation depends on the molecular weight, size, and charge of the ion of the molecules. So, dito tandaan nyo na lang kung saan based yung kanyang mga separation. Kung ano yung ginagamit na separation. Kung size, molecular weight, or charge. Hindi siya masyado namang natatanong sa board exam. So, usually tatanong dito yung kung ano yung reference method. So, yung isa yung gold standard for drug testing tsaka sa newborn. Pero madalang talaga dito sa chromatography. Involves exchange of sample ions and mobile phase ions with the charge group of stationary phase. Stationary phase, polymers are covalently bound ions. Ions with the greatest densities are held more strongly on ion exchange material. Used in the separation for amino acids, protein, and nucleic acids. So usually mga proteins ginagamit itong ating ion exchange chromatography. Next is partition chromatography or liquid-liquid chromatography. So the separation is based on the difference in solubility between two liquid phases, one aqueous and one organic. So types niya is either normal or reverse. So normal phase liquid chromatography uses polar stationary phase and reverse is uses non-polar stationary phase. They are used for separation of therapeutic drugs and their metabolites. Affinity chromatography separates solutes by using immobilized biochemical ligands as a stationary phase. This type of separation uses a so-called lock and key binding. So, kung ano lang yung katumbas niya. Di ba pag may susi tayo, isa lang yung padlock niya. So, kung ano yung where it fits, dun lang siya pwede. Uses in the separation of lipoproteins, carbohydrates, glycated hemoglobins, and antibodies. Next is adsorption chromatography or liquid-solid chromatography. The separation is based on the difference or competition between the adsorption and desorption of solutes. So the compounds are absorbed into a solid support such as silica or alumina. So types of liquid chromatography. High-performance liquid chromatography or HPLC uses pressure for fast separation. High performance or pressure yung ginagamit, controlled temperature and inline detectors and elution technique. Components, solvent reservoir or lalagyan, pumps, pushes and propels the solvent, injector for sample introduction, chromatographic column, so functions as a stationary phase, so dito siya ilalagay, operates at room temperature. So again, the detector, it is where the effluent from the column passes. Solutes are introduced in the order that which they are eluted. Computer, they process the data and control the operating system. So they are used for fractionation of drugs, hormones, lipids, carbohydrates, and proteins. Separation and quantitation of various hemoglobins associated with specific disease, HbA1c. So, ito yung glycated hemoglobin or yung may sugar na hemoglobin. So, this is used to detect yung sugar content for a summary of 3 months ng ating hemoglobin mismo. So, hindi siya affected ng fasting since 3 months summary siya ng ating sugar. So, last is liquid chromatography mass spectroscopy. It requires interferences methods to convert non-volatile to volatile compounds and is used for detecting non-volatile substances in body fluid. Utilized to confirm positive results in from the screening of illicit drugs, complementary for GCMS. So GCMS muna, then liquid chromatography para ma-confirm natin yung drug content. Okay, so that's it. Wait for part 4 of our instrumentation. Thank you.